If you need to pick up a thumbtack, you don't use a 50-ton industrial crane. Yet, when companies integrate artificial intelligence into their workflows, they often default to massive, cloud-based models for every single task, regardless of what the job actually requires. Routing a basic internal document using a 100 billion parameter model is computational overkill. It burns through expensive API calls, introduces unnecessary latency, and forces you to send your proprietary corporate data outside your secure firewall just to read a simple text file. To build smarter systems, we have to recognize that large language model is actually a broad umbrella term. In practice, the architecture breaks down into 3 distinct tiers based on the number of parameters, or learned weights, they contain. Small models under 10 billion parameters, large models in the tens of billions, and frontier models scaling into the hundreds of billions. The engineering challenge isn't acquiring the biggest model available. It is accurately calculating the cognitive demand of a specific business task and mathematically matching that demand to the exact right class of model. True enterprise intelligence comes from strategic orchestration. By right-sizing your AI, you maximize execution speed, minimize operational costs, and keep your most sensitive data locked safely on-premise. Small language models, or SLMs, operate with fewer than 10 billion parameters. These are high-efficiency specialists designed to match the accuracy of much larger models on focused high-volume tasks. Consider document classification. If your system needs to read thousands of incoming files, identify their categories, and route them to the correct department, you need fast pattern matching. You do not need deep philosophical reasoning. Look at this architectural breakdown of the Anven ecosystem. The Model 1 quantized series operates at just 1 to 3 billion parameters using 4-bit precision. This specific configuration is engineered directly for high-volume efficiency. Because of a process called quantization, which compresses the model's weights to save memory, these lightweight versions can run directly on constrained hardware. They integrate straight into ERP systems, mobile devices, or edge nodes, maintaining near-native accuracy with a fraction of the computational overhead. Deploying locally through runtimes like PyTorch Executorch provides an absolute security perimeter. The classification happens entirely within your own infrastructure, meaning confidential financial or healthcare documents are never transmitted to a third-party server. For high-throughput, low-complexity operations, SLMs win by default. They execute quickly, keep costs predictable, and ensure total data sovereignty. Large language models operating in the tens of billions of parameters are generalists. These models are trained across much broader datasets, giving them a wider understanding of multiple domains. This is where you assign medium complexity tasks, like an automated customer support agent. Customer queries are highly variable. People describe the exact same billing problem in a dozen different ways, and the system has to navigate those unpredictable human edge cases. To resolve a ticket, the model must pull a customer's billing history, cross-reference it with technical server logs, and synthesize a coherent, helpful response out of those disparate data streams. To keep that synthesis accurate, we use Retrieval Augmented Generation, or RAG. When a query comes in, the system searches your secure vector database for the factual context, retrieves the relevant documents, and forces the LLM to ground its generated answer strictly in your proprietary truth. A small model would struggle to connect the dots between a server error code and a specific refund policy. The LLM has the parameter depth required to reason through those relationships and generate a natural conversational solution. By combining a broader knowledge base with internal RAG pipelines, mid-tier LLMs strike the ideal balance. They handle dynamic, complex dialogue without requiring the massive infrastructure footprint of the absolute largest models. At the top of the scale, we have frontier models. Pushing hundreds of billions of parameters, these are the most capable reasoning engines currently available, built specifically for deep logic and autonomous tool integration. You reserve frontier models for the highest stakes challenges, like autonomous incident response. When a cascading network failure triggers critical alerts at 3 a.m., the system needs to investigate the root cause and deploy fixes entirely on its own. This requires agentic AI. The model operates continuously outside of a standard chat window, holding a long chain of reasoning in its memory to plan out a multi-step workflow. It reads the system alert, forms a hypothesis, and acts on it. The agent calls monitoring APIs, reads the resulting server logs, evaluates if its initial hypothesis was correct, and then executes the specific code needed to remediate the outage. Trusting an AI with this level of access requires precise alignment methodologies. As detailed in this diagram, techniques like RLVR, reinforcement learning with verifiable rewards, use automated unit tests to strictly validate the model's coding logic, ensuring it only takes actions that are objectively correct. Frontier models consume immense computational power and introduce higher latency. But for mission-critical tasks where you need independent, multi-step problem-solving, that depth of reasoning is an absolute requirement. The industry is moving past the idea of a single, monolithic AI that handles every request. Modern system architecture relies on building an ecosystem, deploying specialists for routing, generalists for synthesis, and heavyweights for autonomous action. Moving away from a single cloud-based API toward this orchestrated ecosystem of local models creates the foundation for sovereign AI. By hosting these architectures on your own private cloud, you can use parameter-efficient fine-tuning to bake your specific industry knowledge directly into the weights. This diagram illustrates how methods like LoRa, low-rank adaptation, actually work. Instead of spending millions to retrain the entire network, you freeze the base model and inject small, trainable matrices into the transformer blocks, adding your proprietary logic at a fraction of the computing cost. Take that a step further with QLoRa. By utilizing 4-bit quantization, you can run that same fine-tuning process on standard consumer-grade GPUs. It brings specialized, high-fidelity AI directly into resource-constrained enterprise environments. To scale intelligently, map your workflows, audit your API usage, determine the exact cognitive load of your daily operations, and match that load to the most efficient model tier available, all while keeping your data securely locked behind your firewall. When you reduce inference costs by up to 90% and anchor every response in your own protected datasets, the technology stops being a recurring expense. It becomes a private digital asset that your organization owns and controls entirely.